This is the first lesson in grade 12 advanced functions. Cycle 1, just to start it up, cycle 1, lesson 0. The reason why it says C1, C for cycle 1. We're going to do a few cycles and we're going to do lots of lessons. This is called lesson 0 because it's actually a review lesson. It's not going to be anything new. And since this is the first lesson, let me just say a couple of things that will apply to all the videos that I record. I am going to try to make them as short and succinct as possible. Normally when I'm teaching a class, I go slow, I take my time, offer chance for people to ask questions. Videos, I have a different idea in mind, and the idea is to get it done as quickly as possible. If something goes past you too quickly, it's the understanding is that you can always rewind it and listen again as many times as necessary until you get it. But we can avoid awkward long videos if I try to follow that rule. Okay, so I'm going to go through this quick and again rewind it if you need to. All right, beyond that, this is also a bit of a different lesson than normal. Usually these videos are going to involve lessons that I'll fill in, and then you will later have a separate homework sheet to do. This one being a review isn't like that. This is actually really sort of the review, the lesson, the homework all in one. And it's supposed to be self-directed. As you can see, this first sentence here, using Desmos or your grade 11 knowledge, determine the characteristics of the following functions. So that all we're going to look at today is it's a reminder of some of the graphs of the functions that you should know. All right. So first off, you should be trying this sheet on your own before you watch this video. Think of this particular video as what you can go to if you get stuck on something and you don't know where to proceed. Then by all means look at this video. But otherwise, if you haven't done so yet, pause the video, work on these questions that you'll find in OneNote, and then just come back as needed to this video so I can walk you through a few specifics that you can look at. All right, so assuming that you're beyond that and you've come back, here's how we're going to approach this. Actually, let me just rewind or backtrack for a second. When we're graphing, we're going to spend a lot of time this semester using the transformation formula. And we're going to review all kinds of stuff as we go along. So there's the formula, and if it looks vaguely familiar but you've forgotten everything about it, don't panic. We'll have lots of time to go over it. But here's just a quick reminder. This transformation formula applies to any kind of function, and it relies on the letters A, K, C, and D. And each one of them represents a different kind of transformation. So A here is always going to be our vertical stretch. And we always tell what our A value is in a function because it's the one that comes right after the equal sign. K is our horizontal stretch. It's the one that always comes inside the function. Whatever that function is, it comes inside it, but in front of the x. D is our horizontal shift. It always comes inside brackets, but after the x. Brackets. And C is our vertical shift. That's the one that always comes at the very end, after everything. It's never inside brackets. And so we can recognize those by where they are. So we'll be coming back to those. I'll probably make reference to it once or twice in this lesson. All right. So again, the purpose of this is to review certain types of functions. I hope that this first type of function that you can see on my screen, 1, 2, 3, 4, 5, is pretty obvious to you at this point. That's a linear function, and you should be able to recognize this one, right? It's like y equals mx plus b, and it's going to be, let me just fill that in, and we can tell by looking at them. Say, let's look at this first one here. We think of it like y equals mx plus b, and in this case, it would be the same as if the equation was actually y equals 1x plus 0. because there's no number in front of the x, it's assumed to be a 1. There's no number after the x, it's assumed to be a 0. Remember, b is our y-intercept, so this one has a y-intercept of 0. I'll graph that on our grid over to the right. It's got a slope of 1, which means that it goes up 1 and 1 to the right, up 1 and 1 to the right, and so on, and it just creates a straight line in this way. And try to graph this on my iPad. Not always easy, but there we go. So we got that one, right? And all these other ones are just variations on this. So if I was just to jump to another one, number 5, for example, it's got a y-intercept of -5, and it's got a slope of -1. So I would go to -5 for my y-intercept, and then my slope is -1, which means it goes down 1 and 1 to the right, down 1, 1 to the right, and so on like that. And again, I can graph that. The other ones, try doing, obviously, do them all just for practice if you haven't already, and but they're all going to be linear. So what's similar about all these? Well, they're all straight lines. And what is different about all of these? They have different slopes. You're going to see when you fill them all in. They have different y-intercepts. They're going to go different directions, either up to the right or down to the right. Okay, next one, quadratic. And again, the reason I know this, again, I hope that you recognize this right away, is because they all have squareds, right? They all have this exponent 2 on it. But beyond that, we can look at things like what's the vertex? What's the direction of opening? What's the vertical stretch? So the first one, again, let's just go through it quickly. I don't think we need Desmos for this one, but of course you're welcome to use Desmos. I'll review using Desmos in a minute. Let's look at the first one. So this first one here, y equals x squared. The vertex is at 0, 0. The direction of opening is up. It's not stretched, so it's just our basic step pattern of 1, 3, 5. So I'll go over 1, up 1, over 1, up 3, over 1, up 5, and do that on each side, and then we can graph it. Just make a nice smooth curve to connect it. If I do one other one, again, if I skip down to, say, number 5 here, I can tell the vertex for this one is -2. Remember, you change the sign for that inside the brackets for the horizontal shift. -2, -5. And it's stretched by 3, so I'll multiply my step pattern by 3. So I go over 1, up 3. Then I go over 1, up 9. And then I would go over 1, up 15, but I don't have enough room for that. And again, just connect the dots, and you've got your... I put that one in the wrong spot, didn't I? Let's move that over. Connect the dots, and you've got your nice U parabola shape. So again, assuming you've done all these, what's going to be similar about them all? Well, they're all parabolas. They're all U-shaped. What's different about these? Well, they all have a different vertex. They have different directions of opening. And they have different stretch factors. Okay, now we're getting to ones that you might not be able to sketch so easily just from your knowledge. Maybe you do. Again, if you can, by all means, go for it. But if not, let's go to Desmos for this one. Just a quick reminder of Desmos. So the first one is 1 is y equals 1 over x. So I got Desmos on my iPad where I'm recording this. Y equals 1 divided by x. You're going to want to get Desmos on your device, whatever you're using, whether it's your computer. You can just obviously do the web-based one. I've got the app on my iPad, which is very convenient. We're going to be using Desmos a lot. There's a sketch of the graph, right? So I got a rough idea of what the graph looks like, or a very good idea of what the graph looks like, to be honest. And you can see it's got those two parts, and it's got, remember, it's got asymptotes if you recall. It's got a vertical asymptote on the y-axis. It's got a horizontal asymptote on the x-axis. Again, first lesson, I'm going to be throwing all kinds of terms around, but we're going to come back to them. So it's going to be kind of a fire hose of all kinds of terms coming at you that you may have forgotten. Don't panic. There'll be lots of time to review them. So there's the first graph. Let's just put a sketch of that on there. It's going to look something like this. And then you can do the other ones. Again, in the interest of not spending too long on it, I'm not going to sketch them all because that takes me a bit of time. But let's do number 2. That's where we take the exact same thing as equation 1, and we just add a plus 5 to the end. So that wouldn't take us much extra effort. So plus 5, what happened? Well, it's moved up vertically, hasn't it? It's moved that horizontal asymptote up by 5. So if I were to sketch that one, then you'd sketch the exact same thing except 5 units higher. And so just play with Desmos, and you'll get a look at what all of these look like. So, what's this one? This is actually called a reciprocal function. And once you got them all sketched, you're going to see that they all have the same two-part shape, like you can see here, and they all have asymptotes, both vertical and horizontal. What's going to be different about them is they're going to have different stretches and shifts of the graph. So it's going to have that same basic design, but it's just going to be shifted a little bit. All right? On the back, the next one, again, they're all the same. If you don't know what this one looks like, then you just type it in. Again, I guess just to show you, you can do it. This is called absolute value. And on Desmos, there actually is an absolute value button. If you look down in the bottom left corner of my screen, above where it says ABC, it says that A between two lines, that's the absolute value. So I can go y equals absolute value of x. And there's the shape. It makes a V shape. Very similar to a parabola, makes a V shape. And again, that's how you type it in. You're going to see it. You can sketch that. I won't take the time to sketch that one right now. But then if I want to do y equals x plus 3, okay, no problem. Just go back, and I can even just adjust it. I don't have to start over. I can just type it in there. What's happened? Things have changed, right? Sketch that one. Still a V shape. What you're going to find is that these ones are all V shape. And again, it's called absolute value. And they are all V-shaped. They all have a different vertex. We still call that point the vertex, okay? So this particular one's got a vertex of -3, 0. So they're going to have different vertices, and they're going to have different directions of opening, either up or down. They're going to have different stretch factors. But otherwise, you know, they're all V-shaped. The next one, you can type that one in Desmos, see how that looks. These ones are called radical. And again, the basic one is y equals the square root of x. Again, I've got that on my iPad here. If you look down just to the right of the ABC, you'll see the square root sign. And you can see it sort of gives that sideways U shape. And then I can change things. Do I want to add something underneath the square root sign? Yeah, I can do that for, say, if I was to do number 4, I just have a +4 under the square root sign. So let's do that one. I'm jumping around. I'm only picking and choosing. Oh, I meant to put that +4 under the square root sign, but I missed, right? So I can fix that. Let me erase that and move back under the square root sign. There's a +4. That gives me a different transformation. So make sure you're typing it in correctly, sketching the graphs. What you're going to find is that they all look like half of a sideways parabola, and some of them are going to have different directions of opening, either to the right or to the left. They're going to have different stretches, and they're either going to have the upper or the lower half shown, depending on, again, what you type into Desmos. And you can do all of this. You can predict all of this, again, going back to this. The reason I showed you this transformation formula to start with is because you can use this to predict things. And again, the better you know this formula, then the more helpful it'll be. Hopefully you've memorized it in grade 11. If you haven't, there'll be time to do it here in grade 12. The last one, you've seen this before as well. This is called an exponential function. Again, in the interest of time, let's just jump right to it. Type these equations into Desmos. What do they look like? Well, they all have a swooping curve kind of shape. For example, the first one, y equals 2 to the x, is going to look like this. It's going to have that sort of upward curve this way. It's going to go along this way. But they're all going to be variations on this shape. Type them into Desmos. See what you get. What's going to be different about them? Well, they're going to have different stretch factors. They're going to have different shifts. They're going to have different horizontal asymptotes. This one, again, has got a horizontal asymptote, which is the one I've sketched has got the x-axis as the horizontal asymptote. And finally, the last one are all trig sine and cos. You remember are trig ratios. When we graph them as y equals sine x, it becomes a trig function. They're all variations on trig functions. Number 1 is just your basic sine function. Number 2 is your basic cosine function. Number 3 is a variation, a transformation of number 1, where it's got a vertical stretch. It's got an a value of 2. It's got a c value of 5. So it's been stretched by a factor of 2 and shifted up 5. But they're all trig functions, sometimes called sinusoidal functions. When you sketch them, you're going to see they all have the same wave shape. That shape that looks like this. Something like that, right? They're going to have different stretches, different period, different horizontal, and vertical shifts.